Okay, hi 4A. This is particularly a shout out to Salina and Saranya for joining us. Okay, anyway, this is the solution to worksheet 12.1 on waves. Okay, let's go on. Question 1. The diagram shows the outline of a wave, water wave. What are the values of the amplitude and wavelength of the wave? Okay, what is the amplitude? Okay, obviously, this is the amplitude, right? 0.6 cm. So your answer has to be either A or B. Okay. What about the wavelength? Now, because we're talking about wavelength, I mentioned before, always look at the axis. Okay, look at the axis before you decide whether or not the graph can tell us information about wavelength or period. For this case, because the horizontal axis is in distance, hence wavelength can be observed directly to be 20. Right, this distance, 20. So answer will be B for this question. Alright, let's move on. Next question. This shows a cross section of a water wave. Which distance measures amplitude? Definitely not D. D in fact is twice the amplitude. Answer is C. Okay, let's move on. The answer is B, but let's see why. Which of the following are true about transverse wave? It carries energy. Okay, definitely true. This is true for all waves. Okay, waves are phenomenon that transfer energy. So this is definitely true. It has compression and rarefaction. This is definitely false. This is a description of a longitudinal wave. Now, 3. Its speed depends on the medium. Okay, if you have done the module on sound, you will realize that this is true. Part 4. The vibration of the particles is parallel. Definitely false. This is a longitudinal wave. And lastly, ripple is a form of transverse wave. Okay, this is definitely true as well. So answer is just 1, 3, and 5. Answer B. Okay, let's move on. Question 4. Okay, this should be question 4. This should be question 5. Wait, let me adjust. Okay, question 4. Which symbols represent amplitude and wavelength? First of all, my attention goes straight to this portion again. I do not care about anything else. Just look at this portion. The axis tells us distance, hence we can observe wavelength. Alright, now this obviously D. I don't think I need much explanation for this. Okay, X, in fact, this X is half the wavelength. The full wavelength is Y. From one crest to another crest, that is one complete oscillation, and hence the wavelength. Okay, this one I don't think I need to go through. What is meant by a transverse wave? In fact, this is the standard answer you give if the question asks you to define a transverse wave or to state what is meant by a transverse wave. Similarly, for longitudinal wave, okay, what are the tendencies to make, where are the mistakes that tend to occur? For this part, some students like to say it is a wave that travels in a direction perpendicular to the wave. You know, it's a repetition. It is not wave perpendicular to a wave. It's wave that travel in the direction perpendicular to the direction of the vibration. What is causing the vibration? Okay, so part C is a repetition of part A and part B. How would you phrase the answer if they ask you for a difference between transverse and longitudinal waves? This is how you present the answer. Name 2 examples of transverse waves and 1 example of longitudinal wave. Quite obviously, longitudinal wave, the only one is sound wave. Okay, nothing else. Transverse wave, there are many waves that we can write. Okay, if you have done the next module on EM spectrum, there are a whole list of transverse wave. Visible light, infrared, gamma ray, X-ray, ultraviolet, and so on. Okay, well, there are more than this. Okay, let's move on. Okay, question 6. look here, this arrow tells us the wave travels from the right to the left. The wave travels from the right to the left. It is known that particle P moves down in the next instant. Okay, wait. This arrow was not supposed to be there. I think this is what you have in your question. Okay, let's do this again. We do not know, okay, let's do this again. We do not know which direction the transverse wave travels. However, we do know that the particle P moves downwards. Okay, moves downwards. It moves downwards. So we look where? To the left or to the right? Okay, for example, if we look to the left of the particle, okay, we look to the left, it is above the particle, right? It is above, and we know that the particle P moves down, which means the direction has to be from right to left. Okay? Okay, 7, I think this is self-explanatory. For the amplitude and wavelength, let's move on. I think this is self-explanatory as well. And we are done. Okay, there are three regions of compressions. Okay, and the distance between each compression will give us the wavelength lambda. Done.